Okay, so we're going to be trying something a little bit different here for this module. Starting here in chapter 4, 5, and 6, the information on the slides are going to be reduced. Okay, not quite so much as information as the first module. Figured you're here now, you've got some idea of what's going on, you've had the first exam, so we can kind of speed things up a bit. Reduce the amount of information so that way you take more lectures, shouldn't take more notes during the lectures, and also you get to see me. That way, you know who's talking and when and what's going on. Now, chapter 4, our first lecture, is going to be looking at and starting to discuss eukaryotic microorganisms. Now, from what we've seen so far, we've discussed mostly the prokaryotes, bacteria, archaea to an extent. Here we're going to be looking at eukaryotes, things that have a nucleus. Okay, so let's look at chapter 4, eukaryotic cells and microorganisms. We need to keep in mind what we think of as living cells, what meets our criteria of living cells: plasma membrane, some sort of a genome, some enzymes for metabolism. Started about somewhere between 3-4 billion years ago. We know this based on fossil record. Now, keep in mind, these are single-cell organisms. They don't leave fossils like the skeletons you go see at the museum. What you ended up having is millions of years worth of single-cell things dying and sinking to the bottom of a stream, a river, an ocean. And over millions of years, those meters of dead cells solidified. Millions of years, geological time, that solidification became different types of rock. So we go and we look at how the strata of rock changes over millions and billions of years. We see there is a change that corresponds roughly to about the time we started to see a real uptick in atmospheric oxygen. That uptick atmospheric oxygen we think was due to eukaryotic photosynthetic cells, the first algae. So we think eukaryotic cells, things that had a nucleus, started about 2 to 3 billion years ago. It's a little fuzzy there. We can't really say, ooh, hey, look, here it is. So 2 to 3 billion. For what we've been able to figure out, all living things on this planet started off with, some what they call the last common ancestor, a protocell, not quite a cell as we would recognize in modern day. It just met our criteria. Had a plasma membrane of sorts, a cytoplasmic membrane, had some genetic material, DNA or RNA, had some enzymes for rudimentary metabolism. Over millions of years, some of those cells adapted, got new abilities. They were able to hang around, able to outperform just a little bit all the other cells. That's evolution. If you can outperform, if you can survive just a little bit better than everything else, your progeny get to stick around. Everybody else dies off. So those first protocells, billions and billions of years ago, kind of divided. One camp became the prokaryotes, things without a nucleus, the bacteria, modern day bacteria, archaea. Those are what we think of those. And the other camp became what we think of as the eukaryotes, things with a nucleus. When you look at eukaryotic cells, modern day, eukaryotic organisms, we see that they fall into one of three camps. First camp, always unicellular, single cellular things. Protozoa fit that. Middle camp is going to be things that can be unicellular, single cell, or can be multicellular. They can clump, they can aggregate, kind of work together. That's going to be fungi and the algae. And then the things that always are multicellular, always have to work together, start to form tissues. Tissues can be evolved to become organ systems. That's going to be the helminths. We'll see later in this chapter what we think of as the parasitic worms.